Hey guys, by now many of you are aware of CNN in deep learning. CNN are widely used for image classification and to some extent in video recognition. Today, we will be exploring another type of neural network. But before that, let's just see what are virtual assistants. Virtual assistants have become quite common in our day-to-day lives. Apple Siri, Microsoft's Cortana, and Google's Google Assistant are all virtual AI. A virtual assistant, also called AI assistant or digital assistant, is nothing but an application program that understands natural language voice commands and completes tasks for the user. They are intended to replace some of the day-to-day functions and responsibilities of people. They decrease the time you have to spend on mundane tasks in order to allow you to free your time to do more interesting, strategic, and hopefully impactful things. Some of the things which it does are to get your daily news and weather update, review your schedule for the day, book a meeting and schedule appointments, get better directions to enable you to go from one meeting to the next, and much more. Virtual assistants are an amazing way to create value by the better utilization of time. They save you time, which you can then use for other better things. This all is achieved and implemented by using recurrent neural networks. So this slide gives us the brief overview of what we are going to cover today, starting with why traditional neural networks fail and what is RNN, the working of RNN, applications of RNN, and finally the types of RNN. So let's begin. Why traditional neural networks fail? CNN has fixed size inputs and outputs. In case of sequential data, the inputs and outputs can be of different lengths. For example, in sentiment analysis, we map the input sentences to one number describing the sentiment of the text. Outputs and inputs are independent of each other. Output for the sequence prediction can vary. CNN doesn't consider output of the previous input for the current input, which is a must for sequential data. Hence, feed-forward makes decision on current input only. Since they don't take past results into consideration, they don't have memory storage and hence it doesn't store past result. Now, what is RNN? RNN is a neural network for processing sequential data. It is a family of neural networks for processing sequential data. They are a type of neural network designed for capturing information from sequence time series data. A recurrent neural network can be thought of as a multiple copies of the same network, each passing a message to a successor. It is similar to the traditional neural network with the added facility of memory state to the neurons. And finally, as I've mentioned before, it is designed for capturing information from sequences and time series data. Wondering what exactly comes under sequential data or what is sequential data? As the name suggests, it is any data in which the order in which it follows matters. Suppose we're given a sentence, it is going to rain today, and another sentence, is it going to rain today? Both contain the same words but have a different meaning. Hence, it depends in the order in which the words come, hence the name sequence. So here text is an example of a sequential data. Some more examples of sequential data are weather data. Given a set of weather data about the weather over time, we can predict tomorrow's weather. The second is image captioning. Given an image, we can give or we can predict a proper caption describing the image. This is achieved with the help of CNN with RNN. And third is stock market data. With this data, we can predict the stock market if it is successful It could yield significant profit for the company. Now we come to the working of RNN. The diagram on the left shows a general representation of neural network. For understanding it much easily, we unroll it to the diagram in the right. That is the layout of the entire network for the sequence. For example, if the network contained 6 words, then it would be a 6-layer neural network. The formula that happens during the computation is given. St is equal to function of f w into st minus 1 plus u into xt, and ot is equal to g of v into st, where xt is the input at time step t. St is a hidden state at time step t. It is a memory of the network. St is calculated based on the previous hidden state and input at the current step. The function f is usually a nonlinear function such as a tanh or ReLU, which is required to calculate the first hidden state. Ot is the output at step t. So we observe that the output of st at time step t depends on the input xt as well as the previous time step t minus 1, that is st minus 1. You may have observed by now that the parameters u, v and w are all the same in all the layers for RNN. If RNN had used different parameters for each layer during training, then it wouldn't generalize for unseen sequences of different length. Let's take an example. On Monday it was raining. It was raining on Monday. These two sentences mean the same thing, though the details are in different parts of the sequence. Parameter sharing reflects the fact that we are performing the same task at each step. As a result, we don't have to relearn the rules at each point in the sentence. Let's now look at some practical applications of RNN. Text auto prediction enables user to type faster and make fewer mistakes while typing. As you type, the device will attempt to guess the word you're typing. For instance, take the sentence, "I'm running late, I'll be there in 5." As you see, after typing the word running, you get late as the next predicted word. This shows that the word late is normally associated with the word running. In case you make a spelling error, autocorrection would help in fetching you the right word. Like here, when we misspell the word there, you get the right word for there, and hence autocorrection is enabled. Another example of RNN is machine translation. Is a great application which uses RNN. It lets you connect with people by translating your language to the native language of the country you're visiting. This way, you're free to communicate with anyone without any language barrier. Another similar application is the speech translation. The app hears your audio and interprets and translates it to the desired language or the native language, and in turn helps people who speak different languages also to be able to communicate with ease. Let's see some few more applications. Name entity recognition. In this, the machine is supposed to identify the name in a sentence. Consider the sentence, Harry Potter is a great wizard. Here, Harry Potter is identified as the name. Consider this sentence also. Harry is the son of a potter. Here, only Harry will be identified as a name, since in the context, potter here means the profession. Another example is sentiment classification. Reviews are given by many people, and the machine interprets and translates it into a rating scale from 1 to 5. Example, the movie was not at all interesting. In this case, the output generated by the machine would be 1. Some few more examples would be word prediction. Whenever you type in the Google search engine, after typing few words, the Google automatically suggests you words which you would want. That is the use case of word prediction. Another example is image caption and machine translation. Types of RNN. The first one is one-to-one. One-to-one means input is 1, even the output generated is also 1. The most basic example is image classification. The second one is one-to-many. Here, the input is 1 but the output generated is many. An example of this is image caption, where you give a single image as an input and the output generated is a caption describing the information present in the image. The third one is many to one, and an example of it is sentiment analysis, as we have discussed it before. And the last type is many to many. The input length and the output length predicted can vary. An example of this